Question 5 from the January 2018 past paper. The regular polygon EFGHIJ. So what that means is from E to F G H I J, and then you don't need to say E again, because from J you would close the polygon there. So this polygon they're talking about. So the regular polygon EFGHIJ shown below has center O right here. Triangle OEF. It's triangle OEF, and back to O you would close it. Is equilateral. That means all three sides are equal in length, and EF is 5 centimeters. Question: what is the name of the polygon shown above? Okay, so you know the name of a polygon depends on the number of sides that it has. It's 1, 2, 3, 4, 5, 6. There are 6 sides, so it is a hexagon. Alright, so it is a hexagon. Good. That's the name of the polygon that you have. So remember, polygon. Poly means many. Polygon, many sides. From triangle, 3 sides, to quadrilateral, 4 sides, and so on and so forth. From the triangle coming up, all of those are polygons. Alright. They say calculate the perimeter of the polygon EFGHIJ. So remember, perimeter. Peri means around. Meter means measure. So it's the measurement around. So the perimeter. Now it is regular. That means all the sides are equal in length. So let's see what happens here. When you calculate the perimeter of it, you have this side 5 centimeters. So far one side is 5. You would do it down here, but I'll just do it beside here to save space. 5 plus, then you have this side, which is also 5 plus, then you have this side, which is also another 5. Now you realize that you have a short way of doing this, but let's just, for this purpose, let's just finish this off. Plus, then you have this side, so you have 5 plus, then you have this side here, that's another 5 plus, then you have the 6th side. All sides are counted for now. So you have 5 and 5 is 10. 10 plus 5 is 15. Plus 5 is 25. So 5, 10, 15, 20. No, yeah, 25. 5 and 5. 10, 15, 20. And this one makes 25, then this one 30. Okay, good. The short way I was saying is that since there are 5 sides, since there are 6 sides, and all of them are 5 centimeters, you could have just said 6 multiplied by 5 is equal to 30. It's centimeters, so make sure you put the unit there. So it is 30 centimeters long. Alright, that's the perimeter. Let's continue, see what happens further. Let's just get rid of these to make space. You know it's 30 centimeters long. Try to remember that in case you have to use it later on. Determine the size of each interior angle of the polygon. Alright, we want the size of each interior angle. So what is that going to be? First of all, for each interior angle, what they're talking about is this angle, or it could also be this angle. It could be, I draw these dotted because these two that they draw are also dotted. It could be this. Alright, any of these angles. That's the size of each interior angle. Now let's see what happens here. Now if you have this, all of this, let me start here, from here going all the way around, this big angle going right around. You know what this angle would be? It would be 360 going all the way around. But then guess what? It is a regular polygon. Since there are 6 sides, the question is, how many parts would this angle be cut up in? Let's see. If you join the center to each vertex, that is to each corner of the polygon, you have one cut, or one slice, 2 slices, 3, 4, 5, 6. You have 6 equal slices. So the 360 degrees have been cut. This big 360 degrees, it has been cut into 6 equal parts. So you're finding out how many 6s are there into 360, and that will be the size of each angle. That would be the size of each slice of the 360. Alright, so how many 6s are there in 360? In other words, 360 divided by 6 is 6 into 6, 1. How many 6s are there into 36? It is 6 of them. And of course you multiply by 10 at the 0 to make it 60 degrees. So here the size of each angle in this polygon is 360 degrees. That's the size of each, is 60 degrees. That's the size of each interior angle. So the size of each interior angle is, and you would do the working here and write down the answer, 60 degrees for part 3. Alright, there's a part 4 here. Show by calculation that the area of the polygon to the nearest whole number is 65 centimeters squared. Interesting. Let me just put the 65 centimeters squared up here. 65 cm squared. So show that the area of the polygon is 65. Alright, how are we going to do that? Let's see. Now, you will of course have different ways of coming up with that answer. Alright, now let us look at one of those methods. The thing is, if you consider this triangle, in your mind it might be that you have a triangle with a base at the top. So let us make a triangle with the base at the bottom. So I want my triangle that I'm looking at to be this one. Alright, so let's concentrate on this triangle for now. Let's take it and put it right here. So I have the I, the H, and the O. So I'm looking at triangle IHO. Now I want to find out the vertical height of this triangle. I know that the width here is 5. How do I find the vertical height? What I could do is consider cutting this triangle into 2 parts and taking it out at this point. So I have half of the 5 here, which is 2.5 centimeters. This slant height is going to be, now remember it says OEF is equilateral, so this here is 5, this here is 5, so the length of each side would be 5. So you can see this will also be 5. Alright, now I want the vertical height. This is just one method of doing it, which you might have been familiar with, alright, before. Now you could use Pythagoras theorem to find this height. So therefore you would say the hypotenuse square, the right angle would be here, so 5 squared is equal to, let's call this y squared plus 2.5 squared. So you would say y squared is equal to, when you transpose it would be 5 squared minus 2.5 squared. Let's draw for a calculator. So what you have here is 5 squared is 25 minus 2.5 squared, so 2.5 squared, that would be 18.75 when you work it out, and that's 18.75. Let me put it right here, 18.75. So running out of space, let's put the rest of it here. Y squared is 18.75, so y would be the square root of 18.75. So when you find the square root of 18.75, you get 4.33. So it's 4.33. Now if you consider half base times height as the area of this triangle would be half of 2.5 times the height of 4.33. Calculate that and see what you get. So 0.5 times 2.5 times 4.33 equals 5.4125. So the area of this here would be 5.4125. Now, having cut it up like this, you would have two of them here. You would have another two. So each would be cut up in that way. So how many would you have? Well, you could see it would be 12. Let's count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of them. So there are 12 5.4125 centimeters squared. So multiply the 5.4125 by 12 and see what you get. Times 12 equal, and you get close to 64.95. Alright, so that is shown. Let's look at another possible way you could deal with it. Another possible way. I did it this way because I think many people might see this as one method that they could use. Alright, because they might have been more familiar with this method than other methods. But let's look at another method you could possibly use. Here you have each section of the polygon like this. Now let's take this one out. This one, I'm putting it here. You have an angle here of, what was it again? 360 over 6, which is 30 degrees. So you have 30 degrees here. Alright? And you're 5. There is this formula that says the area of a triangle is half AB sine C, where you have A, B, and the angle between them C, AB sine C. So let's see how that would work. The area of this would be, our A and B would be like the 5, so it's half by 5 by 5 times the sine of the angle between them, sine 30. Right? You remember what sine 30 was? In this case, if you don't remember, use a scientific calculator and say, oh, make sure it's in degrees, not radians, alright? Or gradients. So in this case, you would say sine of 30 degrees equal, and you will get your half. So the area of this triangle here would be half by 5 by 5 by half, because the sine of 30 is half. So what you would get is half of half of 25. Now if you consider that when you multiply the 5 by 5, you get 25 times half by half is a quarter. You could put 0.25. You get 6.25. All right. So you get 6.25 centimeters squared for each of these rectangles. I mean, for each of these triangles. So this is 6.25. This also is 6.25. So it's this. How many of them? 1, 2, 3, 4, 5, 6. You have 6 of them. So the total area, remember this is the area of each triangle, not the whole polygon. So the total area of the polygon would be 6.25 by 6. So you would multiply 6 by 6.25 here. So this multiplied by 6 would give you 6. So it would be half AB sine C. So 0.5 times 0.5 times 25. Let's see what's happening here. 60 was our angle, not 30. It's 360 divided by 6, right? Should have been, my memory wasn't right a while ago. It would be 60 degrees sine 60. It should be instead of 30. So in this case, instead of finding sine 30, what you would have found was sine 60, right? 0.866. So this number at the end would not have been half. It would have been 0.866. Let's do a little erasing here. I didn't have my previous figures written down. I was trying to remember. So I had the 30 instead of the 60 degrees. So in this case, the proper working would have been half AB sine C, where in this case the sine of the angle is sine 60. So let's erase this, and what we would have is 0.5 by 25 by 25 by 0.866 equal, and you would get 10.825. 10.825. So you have 10.825. If you want it exact, not necessarily, but if you want it exact, what you could do is say half by 5 by 5 by, instead of writing the 0.866, just get the full figure, sine of 60, and you get 10.8253 something another. Alright, but then this is just the area of each triangle inside the polygon, and there are 6 of them. So what you should do is say all of this must be multiplied by 6. So the total area is 10.825 by 6. So let's multiply this figure by 6 and see what you get. 6 times all of this is and you get your close to 65, 64.95 something another. So 64.95 all of that. 64.95 and it says close to 65, so it was shown again by another method. Alright, but as I said, probably most people would think of using the Pythagoras theorem method because that's what they're familiar with. Alright, but whichever method you want to use to show it, it's up to you. Alright, to the nearest whole number is 65 because you would round 64.95 up to 65. Alright, okay, so that's the end of 5a. 5b is talking about a tank and so on and so forth. Let's leave that until another time. I'll see you.